Hello, and welcome to today's lesson on wave behavior. In today's lesson, we will recap how waves can be absorbed, transmitted, or reflected when they encounter different materials. Next, we will learn how different wavelengths of light behave differently. Finally, we will explore the phenomenon of refraction in more detail. So far, we have discussed the basic properties of waves and how they interact with materials. We have highlighted that waves can be absorbed, transmitted, or reflected. We briefly touched upon refraction, a phenomenon that alters the direction of a wave as it passes through different media. We also learnt about electromagnetic waves and the electromagnetic spectrum. Let's get started. First, let's recap wave interactions at boundaries. When a wave encounters a material or boundary, it can exhibit one or more of the following behaviors. Starting with absorption. When a wave's energy is taken up by the material, it is absorbed. The absorbed energy is often converted into other forms, such as heat. For example, a black surface absorbs a significant amount of visible light and converts it to heat, which is why it feels warmer under the sun compared to a white surface, which reflects more light. Next is transmission. If a wave passes through a material, it is transmitted. The extent to which a wave can be transmitted depends on both the material and the wavelength of the wave. For instance, glass transmits visible light but not ultraviolet light, which is why you can see through a window, but it can still protect you from some UV radiation. Finally, we have reflection. When a wave bounces back after hitting a surface, it is reflected. Mirrors are a common example, reflecting visible light to form images. Understanding these interactions helps us manipulate and utilize waves effectively in various technological applications, such as lenses, cameras, and medical imaging. Now let's examine how different wavelengths of electromagnetic waves interact with materials, specifically focusing on thin metals. Starting with radio waves and microwaves, these long wavelength waves are generally absorbed by metals. That's why microwave ovens use metal walls to contain microwave radiation inside the cooking chamber. Next, we have infrared waves. These are also absorbed by metals and many other materials. Your TV remote control uses infrared waves, which are absorbed by the sensors in your TV to change the channel. Thirdly is visible light. Unlike radio or infrared waves, visible light is usually reflected or absorbed by metals. For example, a shiny metal surface can reflect visible light to create a mirror-like effect. Fourth is ultraviolet waves. These shorter wavelength waves are typically absorbed by thin metals. UV radiation from the sun is partially absorbed by the Earth's atmosphere and by certain metals, which is important for protecting us from harmful UV exposure. Finally, we have X-rays and gamma rays. These high-energy waves are transmitted through many materials, including metals. This property is utilized in medical imaging, such as X-rays, where the radiation passes through soft tissue but is absorbed by denser materials like bone, creating a clear image of the skeletal structure. Next, let's delve into the phenomenon of refraction. Refraction occurs when a wave changes direction as it passes from one medium to another. This happens due to a change in the wave's speed in different media. The law of refraction, also known as Snell's law, relates the angle of incidence to the angle of refraction through this equation. Here, n1 and n2 are the refractive indices of the two media, and θ1 and θ2 are the angles of incidence and refraction, respectively. The refractive index is a measure of how much the speed of light or other waves is reduced inside a medium. For example, light travels slower in water than in air because water has a higher refractive index. To see refraction in action, think about a straw in a glass of water. The straw looks bent at the water's surface because light rays are refracted as they move from water to air. Understanding refraction is crucial in designing lenses for glasses, cameras, and telescopes. The phenomenon is also fundamental in the process of focusing light to a point, which is essential for vision correction and various optical devices. In today's lesson, we delved into electromagnetic wave behavior, focusing on how waves interact at boundaries, the behavior of different wavelengths when encountering materials, and the phenomenon of refraction. We recapped three primary wave interactions: absorption, transmission, and reflection. We then looked at how various wavelengths of electromagnetic waves interact differently with thin metals. Finally, we explored refraction in detail, which occurs when waves change direction as they pass from one medium to another due to a change in speed. We introduced Snell's law, which relates the angles of incidence and refraction to the refractive indices of the two media. In the next lesson, we will delve deeper into refraction. Watch the rest of the GCSE physics course at Sophos Education.